So today we'll spend a portion of the time reviewing what we studied before. Some of these questions that we have here could be compound interest or annuities. You have to decide which one this is. Once you've done these two problems, check the solutions that I'll put up in the video within the next couple seconds. And that is the solution to the first problem. And now we'll start the second. And the reason why we do this problem the way we do is because we'll notice that it's a deposit every month or every quarter for 12 years. So our compounding number is 4. And that's why we have this value here and this value here to get this one. And when we do our equation, we substitute accordingly and we get the following answer. So today, we're going to take a look at the payment of an annuity. Basically, let's take a look at the amount of an annuity that we had before. So with the amount of annuity, we had this. A is equal to R bracket 1 plus I to the n minus 1 divided by I. Now, what we're going to do is we're going to rearrange. What we're going to do for the payment of the annuity, which is our lesson for today, is we're going to solve this equation for R. So essentially, if you think about this, we have this I value, which is at the bottom. Now, if it's divided by here, and we're trying to get I by R by itself, we're going to have to times it by the A value. So that's what happens here. So we end up with R is equal to A bracketed with I, right? Now because on this side of the equation, this whole portion is timesed by R. In order to bring it to the other side, we're going to divide everything by that value, and we end up with this as our final answer. So in order to pay for the amount of annuity, this is the basic equation. A times I over bracket 1 plus I to the n minus 1. All those values that we used before, all those definitions that we used before were exactly the same as before. Okay, now let's continue. Just change this FV to A on your note. Now let's continue. Basically, you have your basic equation, and what we're going to do is use that equation over and over again. Now, this lesson will tend to be a lot shorter than the first lesson that we studied. All right, let's move on to page 2. So, the first example is this. Determine the regular payment required to save $10,000 in 8 years if payments are made monthly and interest is 5.1% compounded monthly. Now, in order to do this problem, we automatically know that we're doing regular payments, so we have to bring out Aaron. Determine the regular payment required if $10,000 to save $10,000 in 8 years. So, because it's $10,000 in 8 years, A is 10,000. A is 10,000. Now, we don't know what R is, so I'm just going to put a question mark beside it. We do know what our interest rate is for the year, so it's 0.051. But then we're compounding that monthly, so I'm just going to write 0.051, and then we're going to divide that by 12. Now, N is 8 years, and then we're going to times that by 12. 8 times 12 gives us 96. Now we'll start by calculating. We'll start by using the new equation that we studied today, that we came up with today. So we start with R is equal to A, I, divided by bracket bracket 1 plus I to the n minus 1 n bracket. Now we'll do our substitution. 10,000. And there's our substitution. Now, punching that all into your calculator, you're going to get the following answer. $84.58. So you could essentially say the deposit is $84.58. So now let's move on to question number 2, 3, and 4, and we'll get it done as quickly as possible. So example 2 says determine the semi-annual payment required to come in at $5,000. So now let's start by writing Aaron again. A-R-R-I. So determine the semi-annual payment required to accumulate $5,000. So $5,000 is our start value. And we don't know what R is, but we do know it's going to take 5 years and it's compounded semi-annually. So it's 3.9%. So 3.9% is 0.039. I is this, because the interest rate is divided by 2 because it's semi-annual. And N is this. Which is equal to 60. Start by writing your equation. And doing the appropriate substitution, we get the next line. And we get the following answer. And there is our final answer. Now, let us move on to question number 3. Taking a look, it says, the company needs $75,000 to replace equipment 10 years from now. What quarterly payment is required to raise this money if interest is 4.6% compounded quarterly? So we'll always start by creating Aaron. And reading it through, we find that A is 75,000. R is a question mark. I is this. And N is this. Now do your appropriate equation and do your appropriate substitution to get this. Notice the double bracket that starts the bottom. And now here's our final answer. And we calculate our quarterly payment to be $1,487.27. You'll notice that with each of the problems that we've done, we've always put a final solution to each problem. For example number 4, I'm just going to have to readjust the screen slightly so you can see it. So let's see how I could be a millionaire, or you could be a millionaire if you started at the age of 17 and made monthly payments. How much money would we have to put away each month? So because we're putting monthly payments away, we're going to always start with Aaron. We want $1 million, so A is 1 million. 1 with 6 zeros behind it. We're going from the age of 65 minus 17. So this is the years. Just 65 minus 17, which just happens to be 48 years. Now, our R value, we don't know what that is because we need to find out what our payment is, right? It says that we're paying every month, and we know that our interest rate is 6%. So our rate, R, is 0.06. Our interest per month is 0.06 divided by 12. And then our n is 48 times 12, which just happens to be equal to 576 payments. Now we'll start with our basic equation. Now we'll substitute accordingly. And we get something that looks like this. By calculating R, substituting and doing the calculations, we get the following. So it says we get $299.64 for our contributions. So now my question for you is what the interest earned is. Do the calculations using our contributions like before. So our contributions was equal to N times R. And then we took that number and subtracted from it. Now, the answer that you should get should be about $827,407.36, and that would be your interest. So remember that for you, from now on, if you're able to save $300 a month from the age of 17 for the rest of your life until you get 65, you'll have $1 million sitting in your bank account when you hit 65. Who says they need an RRSP? You guys can save if you can find an interest, an account that gives you an interest of 6%. Do your calculations and show your contributions. It was in the previous lesson that we did. Good luck, guys. Now, do these problems that you have right here. These problems here are what you have to do. Page 154, 3, 4, 17 to 20, 22, 23, and 24. Each equation requires you to do an R value calculation. Some of them will ask you to find your contributions. If you have any questions about contributions, go and check the previous problem set that dealt with interest rates and calculating the contribution. It was at the last lesson of the first video on annuities.